each participants have a secret input, and each of the parties talk to each other in a share secrets among these participants, and these interactions help them to compute some perform some computation on the secret data without actually revealing the inputs. So what does this necessitate? This necessitates a transport layer between all of these parties, because like in real life, we have we communicate with each other via sound or something like that. That has a medium, and that is air. And similarly, in MPC, we require a transport layer. And so I'll just take you through what the current norm is in the industry with respect to this transport layer, right? How this interaction and where this interaction happens. Unfortunately and ironically, this a decentralized setup that we're trying to solve privacy and security currently involves a centralized server like a FireStore or an AWS. Although this is very convenient and easy to set up, it obviously comes with its set of vulnerabilities, right? And the reliance on these centralized servers necessarily shakes the bedrock of the privacy and security that we actually initially sought out for in the first place, right? And that necessarily comes to the, oh wait 1 second. So essentially in our Silence Laboratories two-party protocol also, if in the previous slides Sushi has presented, we allow for FireStore or AWS to be used, right? So we are also not a stranger to this particular ironical norm. And at Silence Laboratories, we've been thinking about this problem like for a long time, and we propose that this norm must be changed. Yeah, and that centralized server is not the way for MPC, and of course we all know the reasons why. And it's a single point of control, which necessarily establishes an authority concentration on one single entity. And when you have a single entity, of course there are vulnerabilities like the denial of service when. And this makes it necessarily the whole MPC protocol implementation in the first place useless, right? We want to implement MPCs to a blockchain for, let's say, threshold signing, and blockchain is necessarily an unstoppable protocol. And here you are introducing a stoppable service in between, and that is necessarily defeats the purpose. And the second thing is when you're dealing with like private data, not necessarily your threshold signing. I'm just talking about MPC on private data. If bunch of these interactions are leaked, it necessitates a privacy concern. This might leak bunch of sensitive data, and this is necessarily not a good like picture for MPC. So yeah. I'm using MPC for blockchain wallets. Here we are asking, does it use decentralized communication, right? But yeah, necessarily it defeats the purpose as the current norm does. Yeah, so what do we need? There is a need for an alternative to for the transport layer to be secure, fast, reliable, and most importantly, not centralized. So this is where we see decentralized network as an option to blend privacy, ownership, transparency, and resistance, right? So yeah, so necessarily as an option, decentralized networks solve most of the problems that we had talked about in the previous couple of slides. It necessarily gets your privacy ownership and gets the onus of the privacy ownership and transparency back to the user. There is the network entirely is censorship resistant. You are not like in a centralized system. You are necessarily there are four to five servers distributed across 3-4 different parts of the world, and here you have like bunch of systems that are communicating between each other, and like working in tandem to make your MPC protocol work. And the last but not the least is network availability. We have a bunch of cases where we see that AWS is down or Google is down, not so often, but yeah, still. But here we can be sure, since there's an involvement of multiple systems in play, you may be the network may be more available. Yeah, yeah. In the recent 2 months, we've been like conducting experiments to see like if we can use decentralized networks for two-party MPC-TSS, and like interestingly, we've had a strategic partnership in Waku, who is a decentralized communication provider, and we, of course, ran the experiments. We replaced the entire two-party setup, all the communications that is happening between party 1 and party 2 that was initially happening in Firebase, and tested in multiple form factors against, of course, the earlier Firebase implementation. And we are comparing a like-to-like scenario in both. Like it's just the message sharing. There is no additional optimizations or computations on top of it. It's just message sharing. And what we see is some interesting benchmarks, right? We are actually very happy with the benchmarks. Firebase, in a two-party setup, a browser and a phone emulator on 2 different laptops, give the whole entire keys in time is around 4,600 milliseconds. This is along with the entire network delays, etc., with multiple messages being shared, and the signing takes 2,000 milliseconds. And necessarily, the Waku light node and full node, which you'll be hearing from Danish more about, there has been comparable performance between the Waku and the Firebase systems. So necessarily, what this necessarily does is provides us hope in terms of getting back the power and control of decentralization back to the user. Now I'll pass the mic on to Danish, who will be explaining more about Waku. Thank you.
Cool. So can I get that? Yeah. Awesome. So we've understood, or at least we've concluded kind of that Waku is the solution, right? But what is Waku? Simply put, Waku is a means to send and receive messages in a decentralized manner, right? And what enables that is this set of protocols that are specifically built around privacy and security in mind. Now, these are some of the reasons why you may prefer to choose Waku in your own application or perhaps your own protocol. We'll be getting in detail with some of these reasons in the coming slides. Now, our modus operandi. We're a public good infrastructure project, which means we're completely chain agnostic, right? So we do not necessitate the need to operate on a particular chain. We're completely open source. We have been since day one. And on the right, if you scan the QR code, you can see the RFCs for all the protocols that Waku has and the security considerations that were kept in mind when the protocols were designed. Now, there are primarily two ways to get started with Waku. The first one is to operate a node yourself. And the second one is to be on the consumer side and build on top of Waku and leverage this network. What does operating a Waku node mean? It means that you're contributing to the decentralization that the network has or which will increase as we have more number of nodes, right? The current state of our network is we are permissionless, which means today you can start a node yourself and contribute to the network, to the decentralization of the network. However, we don't have incentivization in place yet, so you may not earn anything. You might, in fact, be losing money if you're running the node. However, that is a priority for the next 2 or 3 quarters for us, and incentivization is coming soon for the network. But if you like what we're doing and you want to support a public good project, we encourage you to run a node yourself. Also, something that is very important to Waku is spam prevention. It is very easy for a decentralized network to get spammed since there is no way to identify a user since everything is tried to be anonymous. So for DOS protection, we have been working, the research team specifically has been working very hard on trying to solve this, and we've come up with a very solid solution for this. And actually, it says work in progress there, but just 2 days ago, the PR for this was merged to master, and it should be a part of the next release. So we solved this by what we called RLN. It's called rate limiting nullifiers. It's a ZK-based tech that essentially caps the bandwidth or the number of messages a user can send in an anonymous manner. So there is no way to, the user can be rest assured that their identity remains anonymous. For the second facet of getting started with Wakũ, if you scan that QR code, you'll be linked to our documentations where you can find all these SDKs and also details about how to operate a node yourself. It's super simple. You'll have a Docker compose command on the docs. For SDKs, we have JS Wakũ, which is primarily built for browser environments. So if you have a dApp that could perhaps use decentralized communications, JS Wakũ might be the fastest and the easiest way to get started. We also have Go Waku and N Waku, Nim Waku. I don't know how many of you are familiar with the language Nim. But Go Waku and N Waku serve as service nodes or full nodes. We'll get into what light nodes and full node mean as we also discussed earlier in the presentation. We also have Waku Rust bindings and C bindings, if you fancy that. Awesome. So Waku is a family of protocols, right? What makes this possible is Relay. This is the backbone of the entire network. And this is what makes it possible to gossip messages between the peers, right? However, Relay is kind of expensive to run in terms of bandwidth and computation. And I mean, all of us wouldn't prefer to run Relay on our phones, maybe, if you're on data, because you don't want your 1 GB per day plan to get exhausted in maybe a few minutes. So for resource-restricted devices, we've come up with light protocols. And they act as replacement for Relay on resource-restricted devices. The idea is that you don't necessarily have to participate in the gossiping of those messages. You can leverage that network while maintaining a lot of the security and privacy around those messages. So Light Push is a protocol that enables you to publish your messages into the entire gossip network, and Filter is a protocol to subscribe to a particular content topic. While messages primarily are ephemeral for Waku network, we do support temporary storage of these messages. One use case, of course, is, let's say, in a case of a chat application, your device loses connectivity for a few minutes, and you want to have the context of what happened in those few minutes, right? So we've implemented a store protocol. It's the behind the scenes. It's a Postgres. It's a database that's running on each node that is synced across all nodes. We have plans to optimize this. But as mentioned, Waku primarily aims to be an ephemeral network, and this is storage on the protocol is outside the scope of the network. Now, these are some of the use cases that are possible with Waku. We should probably add MPCs there as well moving forward. But yeah, wow, I can't speak. So Waku is a general purpose communications layer, right? The most naive solution is, of course, a chat application. But we can do a lot of things with Waku. And we've seen that with our partners. We've been working with Status, Railgun, XMTP, The Graph, and now Silence Labs as well. And we're realizing the use cases for Waku are very diverse, and there's a lot of things that are possible, perhaps some things that even we don't realize yet. So if you have any ideas of how Waku can be implemented in your project or perhaps in a project or a tech that you are thinking about, please let us know. As for the roadmap, for Q4 of this year, DOS protection, as mentioned, was recently merged and should be part of the next release. So what's left is auto sharding and bandwidth capping. Bandwidth capping is also kind of included with DOS protection with RLN. As for auto sharding, we will be releasing, we've been working very hard at this problem, and we're going to be releasing this in the next few months. As for 2024, our priority remains node incentivization. We really want people to be able to run these nodes and support the decentralization, and also use case specific SDKs. So what we see here, where we would essentially want very directed and focused SDKs for these use cases. Yeah, so we're doing a lot of work and we're actively hiring. If you're interested, if you like what we're doing, we'd be happy to receive and understand how you can help us. Please feel free to scan this. These are some of the roles we're hiring for, but that QR code will help you see that we have more than just these few roles open right now. And all the communication that we do internally, we're completely open source, we build in public. All of the communication happens over Discord. So if you're interested to keep up, if you're interested to contribute, please feel free to check that out. And yeah, that's pretty much it. Thank you. Any questions?
Does anybody have questions? One question there.
Thank you for your talk. So I'm just curious about your performance. How does it compare with the baseline centralized, let's say, chat service or something?
Yeah, that's a very good question. So the simple answer, it depends. And the variables it depends on is the size of the network. Right? Since we can never be sure how big the network is, this works on gossip sub, which essentially means that a message that we relay in the network, we don't know how much time it will take for a particular node that we're observing for that message to reach it. It might be the first hop, it might be the nth hop, and we don't know what that hop number is. So while we can't objectively compare it side by side, we are currently working on metrics for these different network sizes and how these compare. But as we could see with the experiment that Silence Labs did with their own setup, somewhere here, yeah. So here they compared it with Firebase, and these were the results. Now, this, of course, abstracts away the network size metric. We don't know what that was, right? But that is something that we realized, and we are going to come up with the comparison in terms of the size of the network versus the latency.
Okay, so I have another question that there are other gossiping sort of ledgers like Hashgraph, for example. So do you have any sort of idea like or what this provides that doesn't provide or something, some comparison with that?
I'm afraid I don't know specifically about Hashgraph.
It's a gossip-based decentralized ledger protocol, so you can use it as a sort of a bulletin board or broadcast channel as well.
I see. I am not aware of it. Okay. I can check that out and follow up on that. But Waku is built on top of libp2p, which is a modular stack by the Protocol Labs team. And it's also the same gossiping technology that is used by Ethereum, the ETH nodes. So while I'm not sure about what Hashgraph is exactly doing and how they're doing it, I'd be happy to check it out and follow up.
Okay, sure. Thanks.
Any more questions? One more.
Sure. Hi. What's the maximum capacity of the network?
That's a very good question. So in terms of the number of users we can have, the number of messages that can be transferred, like in terms of what?
Yeah, I mean, I guess both, but I guess number of users would be interesting, using it on a semi-regular basis, daily, let's say.
Sure. So the network can currently support roughly 10,000 users. However, as part of our milestone for this year, which we're working very hard on, we're implementing auto sharding, sharding in general, and then static sharding, and then comes auto sharding. With sharding, our theoretical limit we intend to reach is 1 million users. And this should be releasing fairly soon, in the next month or two. Everything's open source. There's PRs, there's work that is being done in public. So if you're interested in this particular topic, feel free to just track it.
Sure, that makes sense. And just as a follow-up question as well, then, you mentioned around the incentivization as well. I guess that's going to be correlated with the number of nodes you hope to have on the network. So roughly how many nodes do you have at the moment, and who's running these? Just, I guess, just to support your project, for example.
Yeah, 100%. So we have, and this changes every minute because we cannot have an overview of the entire network because you actually need to connect with these nodes to know how many nodes exist in the network. There is no holistic view of a decentralized network that can be available. But we did some experiments in the last few weeks, and on browser environments, we were able to discover roughly 100 to 200 nodes. And at a particular time, however, this might not be the case if you try to do it now. It might be 500, it might be 80. As for the people who are running these nodes, these are, of course, our partners who are, since there is no cost associated with leveraging the network right now, so if you, all of this node operators are altruistic in nature. We ourselves, of course, we run nodes to support the protocol. We also have fleets. We have centralized fleets that are currently run in order to bootstrap into the network. So for example, if you want to run a node yourself, your node needs an entry point, right, into the network. So that entry point will be an existing node. It could be my node, it could be Bhaskar's node, it could be a fleet node, right? It needs to be a node that already knows about the network. So, sorry, I was going to say something. But does that answer your question?
Yeah, sort of. But I guess you're hoping that the 500, let's say, you roughly have to be increasing once you launch your incentivization strategy, whatever that is, I guess.
Yeah, so the number of nodes right now is, of course, run by community members. The status team itself runs about, I would say, 6-7 fleets, and each fleet is 3 nodes each, right? Yeah.
Cool, thanks.
Did you say that your nodes are run by altruistic? Nodes are altruistic?
The node operators are altruistic. The people who are running these nodes are not getting incentivized to run these nodes.
How does that work? Node running is purely a profitable business.
Yes, it is profitable once we have incentivization.
Right.
So if I'm running a node today, I'm using my internet, I'm using my electricity, but I'm not actually getting anything in return to run those nodes. We will be incentivizing perhaps on the basis of the bandwidth that the node does. And once there's incentivization in place, the bandwidth that your node is doing, you will get incentivized for the amount of traffic that you actually relay in the network. Does that make sense?
Yes, but I mean, I understand the fact that you don't have a native token to therefore stake and therefore like emit and therefore like earn from or whatever. But like my point is, if this has to survive, then altruism is not enough. There has to be like a strong incentivized testnet, sort of strong nodal structure that doesn't go down in like the worst of times, because that's the whole point of building in open. So I'm very curious about what that will look like in the future. I hope it's beyond altruism though. That doesn't work. Everyone's tried.
100% no, we agree. So we do not have incentivization yet.
Got it. No.
That is a priority for 2024. And that is also something that we emphasize on is while we are permissionless, while one can run a node today themselves, while it's permissionless, you're not actually incentivized to run the node. So you probably don't want to run the node unless you really love what we're doing.
Okay, then I don't want to put you on the spot, and I know that we're fighting against time, but I will ask, when you have 7 fleets, 7 trees, or 21 nodes, do they custody more than 51% of the network at this point in time? Would you say that that is 51% of the network and more?
Yes and no. The reason for that is it's not a black and white question, unfortunately, because we are progressively getting decentralized, right? If you yourself would want to run, let's say, a 50 nodes diversely, you will be the majority also, right? You could potentially be hold a 51%. But with this, we are not claiming that we're completely decentralized yet. We have the network. If everybody here runs the node themselves, we are decentralized, right? The tech itself is decentralized. However, the number of nodes in the network, that is something that we're emphasizing on. The number of nodes in the network are not enough. We're encouraging everybody to run a node.
No, that's completely fair. You don't have to defend. I mean, especially if you're in a nascent state, during building, I think this is a very unpopular sentiment. Nobody talks about it, but you need deep centralization when you start, because otherwise you can't really get to like MVP. But I'm just trying to understand with a non-incentivized structure what future nodal structures would look like. But no, anyway, thank you for that talk, both of you. Thank you.
Thank you. Incentivization is coming very soon.
Okay, on that note, incentivization coming very soon.
Thanks, guys.